Now you see the example of this hexagonal prism. Okay, in the diagram, in the problem given. See, it is given that hexagonal prism of side is 20 millimeter, height 45 millimeter, resting on one of its base. Okay, one of its base. Okay, base edge on HP with base edge on HP with two of its lateral faces parallel to VP. So what do you know what is a lateral face? Means outer face. That is why I have given the previous diagram. There are 4 diagrams of prism or cube or whatever I have drawn. So lateral face means the outer one. End means top and bottom cover. Imagine a prism, hexagonal prism it is. Yeah, top and bottom will be covers. Outside one will call lateral faces. When you open it, 1, 2, 3, 4, 5, 6. You have 6 different rectangles. Okay, some width and length. I mean, base depends on side, and the top portion will be there. That is how you have to understand. Okay. Now, this is one of its. So it's resting on one of its base edges with on HP, with 2 of its lateral faces parallel to VP. So this is the placement. So this information is required for placing the true top view, and you are projecting the front view. That's it. Then it is cut by a plane perpendicular to VP. We have studied section of solids. You know what is a cutting plane means. Section plane means we have to keep it perpendicular or parallel or inclined depending on the question. It is cut by a plane perpendicular to VP. This is a plane perpendicular to VP. Inclined at 30 degree to HP. How to incline? This is HP. The inclination to VP will be, HP will be always drawn on VP. So it is perpendicular, cut up by a plane perpendicular to VP like this, and inclined 30 degree to HP. This inclination or this inclination, whatever it is. So this to HP. Plane meets axis. The cutting plane meets axis of this solid. That is hexagonal prism at a distance of 20 millimeter above the base. From the base, the total height is 45 millimeter. This is 45. From the base at the distance of 25 millimeter, the cutting plane meets the body. Meets above the base. Plane meets the axis at a distance of 20 millimeter above the base. Okay, and it is inclined to at 30 degree to HP also. Is that inclined to HP also? So it is inclined like this, 30 degree to HP, but it meets at a distance of 20 millimeter above axis. At point 20 millimeter at height, you should fix up a plane, cutting plane, section plane, and the inclination to show as 30 degree. This inclination. That is very easy because you have already done many problems in that. And draw the development of the lateral surfaces, means outer one, of the lower portion of the prism. Means you have, when you cut with the plane, you have 2 portions, upper and lower. The lower portion should be shown as the development. That is the meaning. Upper portion, lower portion. Now what to do? My first step is to draw the true shape of your top view and front view. It is over. You can give numbers. I have given PQ is PQ, R, S, T and U. This P are 2 corners. The R and T have opposite ends also. So you have given 1, 2, 3, 4. You can do numbers. Now the work is to cut a plane at 25 millimeter height. Suppose this is my axis. Say at the height of this 25 millimeter, I have to pass a plane. Probably it will come like this. This is my plane. Actually, it should go like this. And this angle is your theta. Theta 30 degree. Okay, this angle is 30 degrees. Now what to do? So this portion is your cut portion. What is asked? draw the development of the lateral surface of the lower portion of the prism. This is cut up, plane is cut like this. So this portion alone you are drawing. That means you think if you take an hexagonal prism, if you make in a paper a model with a, as I told you, either by a normal sheet or a chart, that you make it and you cut it. When you open this bottom portion, what is the answer? When you open it, it will be a different shape. You have side face, 6 faces and that. Now what to do? The simple procedure is, first you draw a line at the same, this height is given 45 millimeter. This you extend it. To what extension? What is this to be extension is? Very simple. What is the total number of sides? Total number of sides of hexagon is a 6 into what is the measurement or dimension of one side? 20 is given, hexagon 20. 6 into 20 millimeter. That is 120 millimeter. 120 millimeter is this your total distance. For that you draw a rectangle and height is 45 millimeter, you draw a rectangle. I will divide this into 6 parts because you have 6 sides only. 1, 2, 3, 4, 5, 6. Like this. See, I am not going to draw an exact sketch here because you have to practice and see that whether it comes properly. Okay. So then what do you do? All these cutting edges. Where is the cutting edge here? This point is 1. Say 1 dash. See, this point is 2. 2 dash. Center you have any cutting edge? No, because it is hollow. Okay, it's a gap. Then third one, this is third. 3 dash. This one 4 dash. And this you have back 5 dash. And this one will have back side also. Hidden portion of second. That's all. So these 3. So how many points? 1, 2, 3, 4, 5, 6 only possible. Now from the cut portions you simply draw or get horizontal lines to the required face where you want it. Now see, these 1 is here. And before that, after writing this, you mark the points. How do you mark? What is your working here? P, Q, R, S, T and U. No, this is P. Okay. Q, R, S, T, U, again P. Because end your folding is, it comes the same point. Whatever the length, it is P out. So opposite side, this you can do it 1, 2, 3, 4 or whatever it is. Okay. Now, where under P you get 1, first point. Then number Q comes 2. 2 where? 2 is down here. Under R you have 3. Point number 3. So this is under 3. This is I write 1 double dash, 2 double dash, 3 double dash, and 4 comes under S. 4 double dash. Then number 5 goes to under R and T. I can have R and T. This T here again. Which one? Number 5. So extend this line. You write here 5 double dash. And 6 goes under 2. 6 goes under 2. You extend this line. It's because 6 double dash. Then last again 1 will be closing with P again, because this is an closing end. You get it twice. Is that right? Because it's like, again remember, it is a closed area only. It's not an open area. You are opening it. You are considering or you are imagining that you are opening a paper. When it is closed, it has the total shape of the body. When you open it, that's called developmental surfaces. That is the basic idea. So this P. Now you join this line. Simply with the scale you join. Again 1 double dash. That is it. Now you see, you have to, using your HB pencil, you have to make it thick. Which portion? This portion alone. Because you need to show, they draw the development of the lateral surface of the lower portion of the prism. Lateral means outer surfaces. See, you could ask me a question, sir, it is a hexagonal prism, you have not shown the top and bottom ends. You remember the previous sketch, I have shown different types of ends. That is not recorded here because not asked. So you draw only the lateral surface, it's enough. So you draw it here. So these remaining parts you can draw with a light, when you 2H, you can use 2H pencil and draw it. This should be shown by, make it very attractive or bright by a HB pencil. That's your development. So only simple thing is, first point is your placement of the object, proper true shape and its projected view, top and front view. Then you are using, you have to go for cutting plane. Place the cutting plane as per the requirement. It is perpendicular to VP, it is in the question, and it is inclined to HP. What angle is this? Angle is given. And it will be given some clue. Either it is say in the center of the axis or the distance of, say, suppose is 45 millimeters total height. So at a 25 millimeter, it is said that it cuts the axis. Which one? Is a section plane cuts the axis at 25 millimeter. So that you draw it. So wherever the section plane cuts in the body, in the view, front view, that point you make it, and that you bring it as a, and before that you make this outermost, what is this called? This is called stretch out line. STRETCH, stretch out line, because it is the outermost line, stretch out line. The inner lines are different faces, and you mark it all the points. Only thing is, in the cutting points, you have to make it, bring all the lines parallelly, and you see that one lies under what? Point P, 2 lies under point Q, 3 lies under point R, 4 under this. Again, this 4 is a corner, so you don't have other edge to cut. It's a corner only. So it goes under this one, you have the backside point, so that you have to measure. So 2 points you will get and finishing. That will give a complete development of your hexagonal prism. Okay? So only by practice you will get a proper idea. Please do it. Now, here is a question about a square pyramid. Fine. So it's a square pyramid, is a shape. Okay? You can hold it anywhere. So it says a square pyramid of 25 mm base, side altitude 50 millimeter. This height is 50 millimeter. Rests on its base on HP with the 2 sides of the base parallel to VP. Okay, this is all your basics. Should know. Cut by a plane bisecting the axis and inclined 30 degree to base. Section plane is cut at where it will bisect the axis, means center of the total axis. So this axis is here, it takes the center. Say suppose this will be 25 millimeter. At 25th millimeter, section plane bisects and it makes 30 degree to the base. To the base you can make, just pull a line. Say this is 25 millimeter, I just cut it. This makes an angle of, your theta is that angle, 30 degree. 30 degree angle. Okay. Now, what is the next step? Draw the development of the lateral surfaces of lower part of the cut pyramid. Again, what is the lower part here? This part. So top portion is removed. You are drawing the lower part here. Now, the only trouble is, actually, a square pyramid of 25 mm base, altitude 50 millimeter, rests on HP with 2 sides of the base parallel to VP. Okay, 2 sides of the base parallel to VP. Now, how do we keep it here? This question is like this. Fine. The center point is your axis. It shows like this. When you bring it to the top view, front view, this all at a different, the height is 50 millimeter, it's fine. But this length, the slant generated, it is called slant edge. Slant edge is not a true length of the slant edge. It is foreshortened. Actually, true length is where these edges or an inclined edges to the point. That means all these or these 4 are this edges. Okay, actually to speak, from the center point the corners are in different angle. So what we do, from this point O, if it is whatever it is, now it is Q point, it is touching Q point, you measure with the compass this Q point and you draw an horizontal line from here, from O, just a normal line, and take your compass, just rotate it, bring to here. Okay, this length is the original length of your slant generator. I mean to say, you project it up to this point, then join this corner with this corner. Can you understand? This is like this. I mean, square pyramid. This is the height. I just shown a cross lines. These are your slant generators. That is, they are not actually a true length of the slant generator. It is only inclined portion. I mean, or it is foreshortened, I can say. So the true length is, you are making this slant, I mean inclined edge into a straight edge. So it becomes straight. Right? That means this corner you made it straight by bringing it to the center. And from the O point, that is a line. That you should join with the top. So this you are joining the top. This becomes slant edge, true length. Okay, the second line is the slant edge, true length. I'll give this point is say Q double dash. This point Q, Q double dash or Q dash. So this is the length you require for developing the pyramid. Now what you do? You take point O. This is your point O, O dash, or this is whatever it is. From this, you just take the length of, you measure it with the scale. Probably it will be some value. Say suppose 75 millimeter, whatever it is, centimeter. You just take it and measure it, 70 centimeter. This may be, so this suppose if this is my O dash, Q dash. Okay, I am just giving an example, O dash, Q dash. So this should be O dash, Q dash, or starting point of that. That length should be O dash, Q dash, but point may be your starting point P, O and P starting. Okay, so this length is this length, true slant edge, true length, or true length of the slant edge. That will make it. From this, now next is very simple. What 1, 2, 3, 4 sides? It's a square, so you need to go 4 sides. Okay, you should have like this. What is this side actually? You have 4 sides. You make one more, 4 sides. Fine, and nothing else is required. You just draw this line. You measure this, right? And this is the side is this OP. Whatever this OP is, this your side OP. Or this you take 4 sides. P, Q, R, S, and P. Okay, that's it. So this is your true length of the slant edge. Slant edge, true length. That's it. Now what you do? The cutting plane, section plane, have cut where you don't bother about this true length cutting point, because inside the body you have 3 points, 1, 2, 3. But everything is not a true value. It's all again a foreshortened value. So wherever it is cut, say suppose this first point you are taking this one, that you make it a straight line, horizontal line to the true length line. And second point, suppose 1 and 2 is this. Yeah, this you bring it to center, and 3 is also as such. Okay. And now from O you measure 1, 2, 3, 4, all these lines you mark it here. 1 will be here, say suppose 2 is here, 2 and 3 will be same, and 4 and again 1. So like this. This will be your lower portion of development, lateral surface of the cut pyramid. That's it. So the only difference in this problem is, since it is the generators, slant edges are inclined or foreshortened, you are making it a true length by just taking an arc or rotating this to a horizontal line. Then you bring it to the XY line. Then they join this point with the O. That becomes your slant edge true length of the slant edge. To that you join this cut points, whichever the section plane is cut. That alone you measure from your point O. Then bring it here, measure it. Then you draw the distance pertaining to this length, true length here, and make it to 4 different segments. That is all. Is it okay? That's how you complete a pyramid. And now we just see a problem under cone. A right circular cone is diameter 60 millimeter and height is 70 millimeter. Okay, its diameter 60 and height is 70 millimeter. Resting on its base on the ground. That is, normally you have to draw the true shape at the top or front view. Now it is in top view the true shape, and projected view is in the front view. Then cut by a plane perpendicular to VP, as it is perpendicular to VP, and inclined 30 degree to HP. Inclined 30 degree to HP. Wherever the inclination is HP. The cut plane or cutting plane, bisects the axis of the cone. That means the axis height is 70 millimeter. The center, that is at around 35 millimeter, the cutting plane bisects. That's what he meant to say. Bisects the axis of the cone. That's it. Draw the development of the lateral surface of truncated cone. Truncated means, I've already told you, if you cut a cone directly with a parallel, the cutting plate is parallel to XY line, okay, or HP, that will gives one the circle. Now here it is truncated means it's inclined. Okay, if it is now the cutting plane. Now the next step is to draw the cutting plane. So the truncated portion you can show it in the developed surfaces or developed diagram, development of the particular right circular cone. Now what you do, you have drawn after drawing this circle and you are 70, showing the axis 70 millimeter, and remaining as which is the marks, you can give all P, Q, R, S, T, all this. I have divided into 12 equal points. So 1, 4, 7, 10, and you will end up with 12. Then what you do, so this point I have taken as O or O dash, and this point is 7 again, 7 or 7 dash you can write. So this 7 dash, which will be your, what is this, true length. O dash and 7 dash will be your true length of the slant edge. This is the true length of the slant edge. Fine? This corner. O dash, and this is O dash and 7 dash. Can you differentiate between the previous, that is your a square pyramid and this diagram? The square pyramid joins with different the slant edges are foreshortened and it's shown in the front view. That is the reason you have taken a straight line from the fixed point O, the center point O, then you brought it to a different line and become that to draw the true length of the slant edge. Now since it is circle here, this is a basis. See, there is nothing foreshortened, so it is directly you can take from this is a straight line, horizontal line. Now I hope you could differentiate the between this pyramid and cylinder, cone. Now here what you do, now point O is, or O or O dash is ready. Now the trouble is, the angle, developed surface, to draw the angle is a question. And before that, the inclined plane, your cutting plane, how to draw, it is 30 degree to HP and bisects the axis. So 30 degree to HP you should take, and bisect if you take, it probably come like this. This will be your 30 degree to HP, theta value that you can mark it. And this portion is the one you are going to now develop. This area will be a truncated one, a different shape. Truncation I told will be looking like this. and bottom will be again a circle. Hope you remember. I have drawn the sketches before to show the truncated portion. So the true length of this. Now to calculate this particular angle, okay, you need to go for a formula where theta is equal to theta or some other angle is equal to, it is your side, that is base of the circle. How much is given? 60 millimeter into 360. That is 360 is total crude angle for a cone, or because the base is a circle, so 360. Then divided by true length of the slant edge. Because the 70 is given as an axis, this true length will be something more than 70. Probably some value. Actually, this question it is supposed to come to be 76 millimeter. So you get a value of say 142 centimeter value. I mean 142 in terms of angle you get, this degree or minutes. Now what you do, keeping this in mind, is 142, this value, for this value you can just draw an arc. Take this length as your say O dash and this 7 dash. I will take O dash and 7 dash should be suppose some other point, a P or Q or S, etc. But this is O dash and 7 dash, this true length of this slant edge, true length of say slant edge, okay, and this O dash 7 dash, this length you take, and for you need an complete the arc for value of 140 degree, you take it this 140 degrees. Now you can just close it, okay. So this angle is your theta. Theta is 142 degree, some minute it will come, okay. Say it's 142 approximately. Now this you divide into how many? You have taken it into 12 different equal parts. You will finish with 12, 1 to 12. So divide into 12 equal parts. S6, 9, 8, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, take 12 equal parts. Then you mark it as P, Q, R, S, T, etc. Then finish it by P. Okay. Now the end is, it is same. Base is a circle. So when you join it, you start with P and end with P1. Okay. And this formula, please you have to remember it. It's nothing but your base circle diameter into 360 degree divided by true length of the slant edge of this particular front view, from the front view. So these cutting edges, 1 dash, 2 dash, 3 dash, whatever edges you have, or you have, instead of telling this, actually you have more than 3 or 4, because everything you have to project it top. 2 points you have in a curve. So this will, you have to take it as such in the previous problems, take it. So all you will have cutting edges in different lines. So all these lines, you bring it to a horizontal, just extend the horizontal line from that point, and extend line, and see that it touches the slant edge, I mean the true length of the slant edge, because everything is foreshortened in this view, front view. So you are making it, and from there, point number O, you measure, and that point is P dash, it is Q dash, R dash, etc. And that one can be measured here, and you just make a points of this, and you will get a point like this. Okay, and the answer will be like this. This is your developed question number 2. See, I am again repeating, it is not a proper sketch, because you need to draw with exact value. So you try it, you will get a proper shape. So the point is how to draw the development. The steps you have to remember. After going for your true top view and projected front view, cutting plane, what are the, according to the given informations, you draw the cutting plane and see that how many edges it cuts. So that edges you keep in mind and bring all these edges into the corner of this, slant edge true length, because to show the true length of the slant edge, and then you mark it PQRS etc. And those points you measure from O, and from this point O in PQRS you can just take an arc for every and complete it. Okay, only this formula you have to remember. That's it.